Greetings and welcome. In this session, we are going to see a procedure to solve a numerical to calculate maximum velocity, mean velocity, and discharge of liquid flowing through a pipe. So let us see a statement of the numerical. A 0.2 meter diameter pipe carries liquid in a laminar region. A pitot tube placed in the flow at a radial distance 15 mm from the axis of pipe indicates velocity of 0.5 meter per second. Calculate maximum velocity, mean velocity, and discharge through pipe. Now, before going to the calculation, for the best understanding, let us take the diagram as per the situation given. So in the statement, the situation is given: laminar flow in a circular pipe with pitot tube fitment. In this diagram, this is a circular pipe shown with the dimension as a diameter capital D, radius as a capital R. This is a pitot tube fitted at radial distance small r, which measure the local velocity small u. The type of flow passing through this tube is a laminar flow. Here we can see the data given in the statement and listed. This is pipe diameter in meter. For the calculation purpose, in the formula we need value as a radius. So radius can be calculated with the formula r is equal to capital D by 2. We find the answer in meter. Radial distance small r is given in millimeter. We have to convert that into meter. At this distance small r, local velocity measured by the pitot tube is given in meter per second. Now, in this numerical, we are going to calculate maximum velocity first. So for that, we need formula. So this formula we get from the theory, that is entrance region theory. So let us have some information about entrance region theory and corresponding formulae for maximum velocity. So in the pipe, in case of laminar flow, as we call this at the axis velocity, that is center line velocity. At the center line here, shear stress means resistance offered by the flow by the fluid to its flow is a minimum. That is why here we find the maximum velocity. As the distance from the axis radially toward the surface increases, in that way shear stress is increasing, and that is why here velocity is decreasing. At the both surface, contact surface of the pipe, maximum shear stress is found. So that is why at these two locations velocity ideally is a zero. It is called as no slip condition. So here we find the variation of velocity curve, which is called as velocity distribution profile in a pipe, and nature of this velocity profile is parabolic. Now here at a radial distance small r, we can see the velocity means local velocity. Now from this theory, first of all we use the relation to calculate the maximum velocity. That is what? For fully developed laminar flow in a pipe, local velocity at radial distance r is given by the formula u is equal to u max bracket 1 minus small r square divided by capital R square. So in this formula, the data which is given, that is local velocity in meter per second, radial distance in a meter, and this is a radius of the pipe, capital R in meter. Putting all these values after the calculation, we get the answer for maximum velocity in meter per second. After that, the second calculation is of mean or average velocity. So for that, we use from the theory, that is relation between average velocity and maximum velocity. Average velocity is half of maximum velocity. So average velocity is equal to 1 by 2 into value of maximum velocity calculated here. We use, after the calculation, we find the value of average velocity in meter per second. Third calculation is for discharge of liquid passing through pipe. Now for this, we use the continuity equation for incompressible fluid, that is Q, means discharge is equal to product of area, cross-sectional area into velocity. So here formula is Q is equal to area into average velocity. As in the data we know the radius, that is why we use the area in radius form, means pi r square for circular pipe cross section multiplied by average velocity. Putting the value from the data and calculation, pi value of r square value of u average calculated. After this calculation, we find the discharge in meter cube per second. Sometimes in the numerical, discharge is expected in liter per second. So we can convert discharge from meter cube per second to liter per second by multiplying this value with 10 raised to 3. So here is a discharge through pipe in liter per second. So this was the procedure to calculate maximum velocity, mean or average velocity, and discharge of liquid passing through a circular pipe for laminar flow. Let us meet in the next video session. Thank you.